So how we can calculate this? So we have a relation between the exit velocity and the chamber pressure and other parameters. We already discussed those points. So then what we can do, we relate the Mach number with, so the flow is isentropic, which is considered. The expansion for the exit Mach number can be expressed with this formula. This formula gives the exit Mach number, because exit Mach number is related with exit velocity. So VE is equals to ME times radical of gamma RTE. Okay, so this gamma RTE is the sound speed of particular gas. This is the speed of sound. Okay, so from that relation we have 2 over gamma minus 1 PTE over PE, the power of gamma minus 1 over gamma minus the whole one. So this is exit Mach number. So which gives 4.9. This is almost Mach number of 5. So the gas flows through exit with Mach number of 4.9. That means high velocity. Okay. Now you can actually find the exit velocity also. Okay. Once you know the exit Mach number, once you know the specific heat. Yeah, get in please. Yeah. Then. Salama. So once you know the specific heat ratio, once you know the gas constant, and then once we know the temperature at exit, then we can find the exit velocity from this relation. Similar to that, temperature at exit is equal to temperature at inlet. This is just inlet, as I told you. So pressure at exit over pressure at inlet. So which are given as the exit pressure is 5.5, as you see from here. Exit pressure is 5.5. That is fully expanded condition, means the exit condition, divided by the 5750. That means the gas pressure. The gas pressure. This is megapascal. So when you use it to metric system, you can this times the power of 6. Okay. Okay. Here it is kilo. Here it is. So you can multiply this by 10 to the power of 3 to make similar unit. Don't forget the unit consistency. So this is 5,750 kilopascal, and this is 5.5 kilopascal. So you see the difference, the pressure difference. At the inlet, it is 5,750 kilopascal, but at the exit, it is 5.5 kilopascal. So substitute those things, and then what you can get is the temperature at exit. The inlet temperature is 2,800, but exit temperature is high temperature drop within from inlet to exit. Okay, you can observe high temperature drop here. Okay, so once we know exit temperature, yeah, here one thing left, we don't know exit temperature. So exit temperature is calculated from here. Then exit velocity is directly obtained from Mach gas constant, exit temperature, and the specific ratio, okay, heat ratio. From that, exit velocity is 2,612.66 meter per second. That is the exit velocity. And for maximum flow to occur in the nozzle, the throat of the nozzle must be choked. That is the choked condition. We have discussed the choke condition of the nozzle. So we have mass flow rate is equals to density at the throat times area at throat times throat velocity. But the throat velocity is equal to the sound velocity. It is because it is in Mach number 1. So that V throat, V star here is V throat, which is equal to radical of gamma RT. Simply it is gamma RT. So from that we can find the mass flow rate at throat. So, but in the density at the throat for choked condition can be obtained from this calculation. So this is the density formulation. So which is equals to 2 over gamma plus 1 raised to 1 over gamma plus 1, the whole times pressure at throat inlet divided by RT inlet. So just substitute all the values of the given parameters, then finally we can get 3.85 kilogram per meter cube. This is the density at throat. Once then the temperature at throat for choked condition can be T star is equals to 2 over gamma plus 1 times temperature at that inlet. So which gives us 2488.9. Look, the combustion chamber temperature is 2800 or 2800 Kelvin. But within a very short period of time, this burned mass of the fluid or the propellant comes into the throat inlet. At the throat inlet, the temperature dropped from 2800 to 2488.9. So that is, you can even check the amount of temperature drop from combustion chamber to the throat. So this is the throat temperature. Another, the velocity at the throat can be estimated as just simply similar to A star, which is equal to rho RT. So you can use rho times R times temperature at the throat. So that gives you 533.2 meter per second. So this is still lower velocity if you compare it with the higher velocity at the exit. Look, at the exit, velocity is 2612.66, but at the throat, velocity is 533 only. So it is very high difference because after throat, the flow becomes supersonic, so that a high velocity gain will occur at the exit. Okay? So consider those things. And the exit density of the exit density of this gas, we can evaluate it from this equation. So rho exit is equals to what? The pressure, exit pressure times this 25 is what? It is just okay. Yeah, exit density. We have a relation for exit density somewhere. Yeah, pressure and density relation. We can use that. Yeah, we have this kind of relation. Pressure at any point. So density, yeah, density at any point. For example, if I consider this as density, exit density, then this should be exit pressure. So we know these values. We know this value, so we can formulate it in terms of this value. So exit density is related with such relation. Yeah, this is ideal gas constant. This is 683 is the value of 683. Yeah, that is exit temperature. Okay. Yeah, then after where we can go? we can go for nozzle exit area. Nozzle exit area can be obtained from the conservation of mass formula. So if the mass is conserved, that means the throat rho AV equal to the exit rho AV. Means if we consider some specific location with full information, then we can use that. So rho AV of the throat is equal to rho AV of the exit. Using that, we can find exit area. So exit area is equals to rho AV of the throat divided by rho AV of the exit. So from that, you can easily find this formula. This value 16.4 meter. Exit area is 16.4 meter, and I may in some other quizzes or assignments I may ask you to find the exit diameter so that you can find the diameter from this. Diameter is equals to pi over 4 d square. Area exit is equals to area exit is equals to pi over 4 d square, d exit square, so that you can easily find the exit diameter of this rocket. Not only the exit diameter, the throat diameter also. Here the throat throat area is already given. Yeah, that is already given parameter. So you can find the diameter of throat also. You can find the diameter of exit. You can find the diameter of combustion chamber. Okay, so by doing that, we can design an appropriate shape of nozzle. Again, another relation is the expansion area ratio thing. That means area at any particular section divided by area of throat, which is equals to the symbol. We discussed about this symbol, that is radical of, we already discussed about this symbol. It's better to give a specific name. Okay. Okay. Yeah, this is gamma times 2 over gamma plus 1, the power of gamma plus 1 over gamma minus 1. So we have to understand this formula of the symbol. So we can simply say some, I don't know exactly the name of this symbol. So you can put that formula here, okay? And then this is area ratio. So this area ratio helps us to find what is exit area, what is throat area, what is the combustion chamber area. Then once we know areas, then we can change it to diameter and radius, because it is circular phenomenon. So this is one of useful formula. So is it clear, by the way? Hello?
ያው በጣም ብዙ ነው ለማንበብ እንሞክራለን።
ችግር የለም። እሺ መጽሐፉን ልከላችኋል አይደል? ይሄን
አለን።
በቃ ስለዚህ ከመጽሐፉ ላይ እዩት። Anyways, there are some explanation here related with area ratio or expansion ratio. Expansion area ratio relation. Let me say. We can, so this is simple relation. So this equation depicts the relation between the expansion area ratio and the local pressure ratio. So it simply you can say pressure ratio are here, area ratio. Even there also for this symbol there is specific properties ratio. So we can evaluate the area ratio directly for a given pressure ratios and a specific heat only. Okay, so this is what you have given, for example, specific ratio 1.2, 1.4, 1.3, and then area ratio can be obtained from directly floating P2 of entrance over P exit ratio is there. So for particular ratio of pressure, we can go and we can find the area ratio. So let's see the nozzle phenomena here. This is nozzle entrance or the gas entrance region. This is the throat. So till throat, the divergent region having Mach less than 1. That means pressure less than 1. That means velocity is very small. And once it passes through the throat, Mach is equals to 1. And then the remaining region is for the supersonic region, that is Mach greater than 1 region. So this is what we are explaining here. ኦኬ ለዛሬ ከዚህ በላይ እንትን ከምንል በዚሁ እናቁምና የኮንቨርጀንት ኖዝል ጂኦሜትሪ ምን መሆን እንዳለበት ኔክስት ላይ የተለያዩ እነዚህ አንግሎቹ ምኑም እንዴት እንደሆነ እንትን እንላለን። ሌንግዝንም ዲተርማይን ለማድረግ እንሞክራለን። So I think this is enough for today. If you have any question, just you can ask.
ዶክተር ቅድም ያየናቸው ማለት ነው የቴርሞዳይናሚክ ፕሮፐርቲዎቹ የኤሮዳይናሚክስ ላይ ያሉ ፓራሜትሮች ናቸው አይደለ? ማለት ስፔስ ላይ ሲሆን አስትሮዳይናሚክስ ፓራሜትሮቹ ሌላ አይሆንም፣ ፕሮፐርቲ አይቀየርም፣ ያው ነው።
እነዚህ ቻፕተር 2 ላይ ያየናቸው እነዚህ ነው አይደለ?
እነዚህ ጋስ ኮንስታንት እነዚህ ነው።
እነዚህ ተርሞዳይናሚክም ከዚህ ነው ከተርሞዳይናሚክ ነው ድራይቭ የተደረጉት። ስለዚህ ኤሮዳይናሚክ ጋር ብዙ ሪሌሽን የላቸውም። ለምን ኤሮዳይናሚክስ ላይ ሞር ኦፍ አንተ ሲፒ ለምሳሌ ምንድነው ይሄ ሲፒ ማነው ሲዲ ኤልዲ እነዚህ ድራግ ኮኤፊሻንትስ ደግሞ ሊፍት ኮኤፊሻንትስ ሞመንት ኮኤፊሻንትስ ናቸው በኤሮዳይናሚክስ ላይ የምታገኛቸው። እነዚህ ግን ፉሊ ተርሞዳይናሚክ ኮንስታንት ናቸው። ከሂት ከኤነርጂ ከኢንተርናል ኤነርጂ ከኤክስተርናል ወርክ ደን ጋር የተያያዙ ነገሮች ናቸው እነዚህ። ስለዚህ there is difference። ተረዳኸኝ? ልክ ነኝ? ምንድነው እዛ ላይ ሞመንት ኮኤፊሻንት፣ ሊፍት ኮኤፊሻንት፣ ድራግ ኮኤፊሻንት ይሄ ሲዲ አት አልፋ ኢኳልስ ቱ 0 ምናምን የምንላቸው እነዛ የስቴቢሊቲ እና የተለያዩ ኮኤፊሻንቶች ናቸው። ስለዚህ እነዚህ ደግሞ ተርሞዳይናሚክ ኮንስታንቶች ናቸው። ሲፒ ማለት ለምሳሌ ስፔሲፊክ ሂት አት ኮንስታንት ፕሬሸር ማለት ነው። ሲቪ ስንል ስፔሲፊክ ሂት አት ኮንስታንት ቮሊዩም። እነዚህ አዲያባቲክ ፕሮሰስ፣ አይሰንትሮፒክ ፕሮሰስ ምናምን የሚባሉ የተርሞዳይናሚክ ፕሮሰሶች እንትን ነው። እነዚህ አሁን ለምሳሌ ኤች ስንል ኢንታልፒ፣ ኤስ ስንል ኢንቶርፒ እያልን የምንሄዳቸው እነዚህ የሲስተም ዲስተርባንስ፣ ለምሳሌ ኢንትሮፒ ስንል የሲስተም ዲስተርባንስ ነው ቢኮዝ ኦፍ አዲሽን ኦፍ ሂት ኤንድ። ስለዚህ በእንደዛ ዲፋይን የሚሆኑ ፓራሜትሮች ናቸው እነዚህ። አት ዘ ሴም ምንድነው የሚያደርጉን? ፕሬሸር እና ቴምፕሬቸር ምን አይነት ሪሌሽን አለው? ፕሬሸር እና ዴንሲቲ ምን አይነት ሪሌሽን አለው ከዚህ በተርሞዳይናሚካሊ? ስለዚህ ያን የምንማርባቸው ናቸው። ሌላ አንድ እንትን ያልኩት ከገባን ቶሎ ስለማንወጣ የታውኩት የስቴቺዮሜትሪ አሁን እዚህ ጋር ብንመጣ ፉል ኦፍ ኬሚስትሪ ነው። አሁን የፊውል ኮንተንት ስንት ነው? የኦክሲዳይዘር ኮንተንት ስንት ነው? ዊዝን a given propellant formulation, what is the content of fuel? What is the content of this what we call oxidizer? ያን ዲሳይድ የምናደርግበት ነው። ይሄ ሪያክቲንግ ሲስተም ጋር ስንመጣ ይሄ ደግሞ ኬሚስትሪ ነው ፉል። ይሄን እንትን አላልኩም። ለምን መጀመሪያ እንትን ላይ ወደ ኢምፖርታንት ማቴሪያል ወይም ደግሞ የሮኬት ማቴሪያል ማጥናት ስንጀምር ወደዚህ እንመጣለን። በእርግጥ ይህን ኮርስ የሚሰጠው ሃይ ኤነርጂ ማቴሪያል የሚባል ኮርስ አለ። እኛ ጋር ማስተርስ ስናስተምር ወይም ስንማረም ሃይ ኤነርጂ ማቴሪያል የሚባል አለ። በሱ ነው የሚሰጠው ይሄ ኮርስ። ራሱ የቻለ ትልቅ ኬሚስትሪ ነው። እናንተ ጋር ግን ይሄ ኮርስ ያለ አልመሰለኝም ሲለበሳችሁን ሳየው። So ለምሳሌ simply H2 plus half O2 which gives you H2O plus delta HR. አሁን እነዚህ ምንድን ነው ኮንተንታቸው ብለን ስንል 2 ግራም ኦፍ ሃይድሮጅን ሲደመር 16 ግራም ኦፍ ኦክሲጅን ምንድን ነው የሚሰጠን? 18 ግራም ኦፍ H2O plus some redundant output አለ እና ስለነዚህ የሚያወራ እዚህ ውስጥ ደግሞ ምንድነው ማስ ኦፍ ኦክሲዳይዘር ዲቫይደድ ባይ ማስ ኦፍ ፊውል this is known as stoichiometry የምንለው እሱን ነው። stoichiometry ስንል the relation between the mass of oxidizer to the mass of fuel። በዚያን ጊዜ ደግሞ አንዳንድ ጊዜ lean mixture የምንለው አለ፣ rich mixture የሚባለው አለ። if we are get a full combination means ብቻ fuel to oxidizer ratio or oxidizer to fuel ratio lean ሊሆን ይችላል፣ rich ሊሆን ይችላል። ስለዚህ ያን ዲሳይድ የምናደርግበት ነው። ኦኬ ሶ ይሄ A over F ኦኬ። ስለዚህ ኦክሲዳይዘር ማስ ኦፍ ኦክሲዳይዘር ኦቨር ማስ ኦፍ ፊውል የሆኑ የተሰጠ ኬሚካል ኢንግሪዲየንት ላይ ቼክ እናደርጋለን። ያን ሳናደርግ ያን ፊውል መጠቀም አንችልም። ሶ ያንተ ጥያቄ ተመልሷል። እኔ ተጨማሪ ሌላ ሐሳብ ውስጥ ሌላ እንትን ገብቼ ነው። ኤኒዌይስ አይ ዶንት ኖ ጊዜ ካገኘን ይሄንንም ማየት የግድ ይለናል። አሁን ለምሳሌ C3H8 plus 5O2 ብንወስድ ምንድነው ይሄ? አሁን በእርግጥ እዚህ ጋር ሂት ኦፍ ፎርሜሽን ምንድነው፣ ሂት ኦፍ ሪአክሽን ምንድነው፣ ሂት ኦፍ ኮምበስሽን ምንድነው የሚለውን ለማውራት ነው ይሄ ፓርት። እና የተለያዩ ደግሞ እንትኖች የተለያዩ ሂት ኦፍ ሪአክሽን ሂት ኦፍ ፎርሜሽን እንዳላቸው እዚህ ጋር ብቻ ይሄን መጽሐፍ በደንብ አድርጋችሁ ግፉበት። እንትን ለማለት ትንሽ ከባድ ነው ከቨር ለማድረግ የተለያዩ ነገሮች ስላሉ ማለት ነው። what is adiabatic flame temperature? please refer it. adiabatic flame temperature ስንል ምን ማለታችን ነው? የተለያዩ ለምሳሌ ሚተን አለ፣ ሃይድሮጅን አለ በጋዝ ፎርም በኤር በተለያዩ ቴምፕሬቸር እና ስለ ኬሚካል ኢኩሊብሪየም አሁን ይሄን በምንም ሂሳብ ሸፍነን የምንጨርሰው አይደለም። ጊቭስ ፍሪ ኤነርጂ የሚባል አለ ደግሞ ጊቭስ ፍሪ ኤነርጂ ያ ጊቭስ ፋንክሽን አለ። ራሱ የቻለ አንድ ኮርስ ነው ይሄ እና ነምበር ኦፍ ሞልስ ኦፍ ሳብስታንስ ራሱ የምንፈልግባቸው ሜቶዶች Yeah, so this is all about today. ጥያቄ ከሌላችሁ ማለፍ እንችላለን። Hello.
አለን እየሰማን ነው ዶክተር። ያለው ያለ አይመስለኝም ከዚህ በኋላ
እየሰማን ነው ዶክተር።
አይ ቲንክ ያለው ጥያቄ ያለው ሰው ያለ አይመስለኝም።
እሺ፣ ስለዚህ ይህን መጽሐፍ በደንብ ገብታችሁበት እዩት። እንዲሁ የምንጨርሰው ስላልሆነ እኔ ቤዚክ የሆኑ ከሮኬት ጋር የተያዙ ጉዳዮች ላይ እያወራው ይዛለ፣ እናንተ የቀረውን ደግሞ ግፉበት። ምክንያቱም ሃይ ኤነርጂ ማቴሪያል ራሱ የቻለ አንድ ኮርስ ነው እና ለመስጠት ብፈልግ ኦቨር ነው የሚሆንብኝ።